Okay, as part of introduction, as part of the agenda, I would like to cover introduction of the cluster and pacemaker, features of the pacemaker and the cluster architecture, and the setup demo that I have prepared with the virtual machines. Though there are some limitations, but still we'll see how far it is going. Okay, so basically cluster refers to a group of computers, or in cluster terminologies we can call it as nodes configured to work together as a high availability system. The main purpose of the cluster is to have high availability, and Pacemaker software is the software which we are going to discuss. Just going to help us as the resource manager, ensuring that the critical services are available even if one or more nodes fail, by automatically transferring the service to functioning node within the cluster. So that's the job of the Pacemaker software. You're going to uh, do a cluster based on this Pacemaker software. Okay. Coming to the features of the Pacemaker is an open source which we can use. So if you see the feature, it has the ability to detect the detection of recovery from node and service level failures, ability to ensure data integrity by fencing faulty nodes, support for one or more nodes per cluster, support for shared storage, support for practically any redundancy configuration. Could be active passive or active active or whatever. Automatically replicated configuration can be updated from any node. Synchronization and all that is taken care, and ability to specify cluster-wide relationship between services such as ordering, co-location, and eco-location. Okay, so it's a feature called fencing, which is also known as stone it, shoot the other node in the head, which is the ability to ensure that it is not possible for a node to be running a service. So this is the function of this feature. This is accomplished by the fence devices such as intelligent power switches that cut power to the target, or intelligent network switches that cut the target's access to the local network. There are many ways we can, there are at least two ways that they are showing here to implement this fencing. When Pacemaker represents fence devices as a special class of resource, Pacemaker is also having the ability to implement this fencing for the devices that we configure. Cluster can safely recover from certain fail conditions, such as an unresponsive node without fencing. So these are the things about fencing. So coming to the architecture of Pacemaker, if you see the one at the right, I'm showing the left picture at the left. So these are the very, very high level block level things which are there in the Pacemaker. One is the cluster resource manager. So as we have just now discussed, that cluster is nothing but a group of nodes managing a specific resources for high availability. So there's a resource manager, which is a key component, and this is being taken care by Pacemaker. There's a local resource manager and the resource agents, which helps us to interface or interact with this resource manager, either to stop, start, monitor, all that. And we have another thing is messaging and membership module or a component in the Pacemaker, which helps in communicating between all the nodes, and that's nothing but the CoroSync, which manages the cluster membership and communication between all the nodes. So there is a thing, if you see at the right-hand side, I've just picked this picture to just show the another view of the Pacemaker architecture. So at the bottom, we have the hardware, which is nothing but the nodes. There are 4 hosts which are shown here. On top of it, we have this CoroSync layer, which takes care of communicating between this host. So it keeps monitoring all of these hosts for healthiness of the node. And on top of it, we have the Pacemaker, which is the actual cluster software managing all the resources. So, and above that, we have all the services, and the services are the important part here is distributed replicated block device. DRBD is used to create highly available storage uh, by mirroring block devices such as across servers in cluster, essentially allowing for seamless failover. So this DRBD, which is distributed replicated block device, is responsible for managing the shared storage, and this is actually managing the shared storage by mirroring all the information on the shared storage and making it available in case of failover. So this is the component which is taking care of that. And services wise, we can have file sharing service, website service, database. So all of these things can be used uh, as services that are supported by the cluster and can make it available throughout for the high availability part. Okay, so this is a sample scenario that I have taken up. So at the bottom we have basically one, two.
Alex, just one question. Yeah, if you go back to the previous slide, please.
Yeah.
So now, okay, so we can see the different layers here: CoroSync, Pacemaker, and then the services. So now, as part of a package or a compiler, let's say, that it comes under the Pacemaker package, will be consist of all these services, or we have to set up separately this one?
Okay, so coming to the package, anyway, I'm going to tell that. So there are two repositories which is responsible for doing this. One is the high availability repository, and from that we will have all the things. So it's better to install group install high availability. That is one which is responsible for doing these high availability related packages are present in that cluster in that repository. And the other one is the resilient storage. So these are two repositories we will have to enable in our subscription manager. And once we enable that, we can start installing those packages in our servers and nodes or servers or nodes.
Okay, and this is open source or free available?
Correct. So yeah. So yeah.
Okay.
So this is freely available. I have tried it with CentOS. Yeah. So so far, I mean, I have not paid anything to make it work.
Okay.
But I have not used many features like fencing and other things. Maybe if I try that, maybe is it going to ask any payment or not? I'm not sure, but very limited thing. But that again, I have a virtual hypervisor which is having the shared storage is not working that great. However, because the shared storage which is being controlled by the SCSI server was having some issues in getting this LVM available in all the nodes, thinking of the LVM nodes. But however, by some other what to say workaround or roundabout things, I made it syncable. So whatever is available in one node is available. I mean, it is visible to the other nodes in the cluster.
Okay.
Yeah. So Shafi, so you have cluster setup already in your environment data center.
Yeah, but it is there, yes, in production. But also, plus there will be like a fresh installation also. Both is there.
I see.
So
Okay.
yeah, so already
so
existing is there. Just to answer your question, and plus there will be like a new setup also. going
So
to
already
be?
existing is the same thing, Pacemaker, CoroSync, and
Yes.
ICKC.
Yes.
Okay. Yeah. So it's pretty straightforward only. Or I'm not paid anything except for the LVM. I had some issues. LVM2, LVM on the clustered LVM. There is one thing. So CLV
Okay.
MD. So there is one package that was responsible for syncing the LVMs across nodes. So that was
But we will
having.
be going through the installation process, during the session to see, because this is something that we were waiting for this,
Oh, I see.
like while
Oh,
like
you
for
want to?
example,
Oh, yeah.
yeah, you will go through this one. We will
Yeah. So
we
the
will
steps are
let you wait for this one, but yes, yeah,
sure. Okay. So if you are interested, maybe, then in that
yeah,
case we may have to let's see how far we can complete. It may
okay,
take a
okay,
lot of configurations, lot of steps are there. So,
okay.
so
But
yeah, I have.
we would say yeah, this is the main core of our training. This is why we opted for the training. This is like main interest of ours,
Oh, I see.
our film. Yeah, you
Okay.
get me.
So yeah.
So we
So
are we are waiting to go step by step with you. We understand there will be configuration, but yes, we want to witness this. We want to understand
sure, not
and
an issue.
learn it.
So
Okay.
not an issue.
There will be
Maybe.
complication. There will be issues. I agree
Uh,
with you. But
Yeah,
yeah,
maybe not a problem if that is what is your main thing. Then probably we can split
yeah.
this into two class and then take it. So that's not
No
an issue
problem.
for
No
me.
problem.
So I mean that if you're serious in that level, then
Yeah.
probably yeah, it's not an issue. Uh, yeah. Okay, so I've taken a sample scenario of having an ICKC server. Uh, uh, one server I have taken and two ICKC clients, the one at the left and the one at the right. These two
Mhm.
are acting as a ICKC client as well as nodes of a cluster. So this is the one, and this is node 1 and this is the node 2, which are part of the cluster. However, they are actually acting as a as ICKC client as well. So in this ICKC server, I've created a shared disk and then made it available for these two nodes, and I've mapped it the using the ICKC thing. So I have mapped it over here, and so these are visible to these nodes, and these nodes are used for cluster. So these two nodes, this is a two node cluster. So two nodes are connected to a cluster, and they speak this CoroSync thing. This is the line which is showing this CoroSync. And there's a virtual IP server that I have taken. This is the one. So this is the virtual IP server which will be made available for all the clients. And I have taken a web service as the sample for demonstrating the high availability. So this web service will be available in this virtual IP for these clients. Invariably, the nodes are, if even the one of the nodes go away. So that's the idea. So if one node goes off, so the things would continue to work. So that's what is the idea of this.
Can 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 we ask the question? Don't know, like if we can see
Yeah.
our sketch here. No, we can see something we are drawing. No,
Yeah. Yes.
cannot see. Nothing, huh?
Shafi, I didn't get you.
Yeah, no, we have a question here. Now you see, let's say you have node 1 and node 2. It's very clear for us. So it will be like two node cluster. So now let's say,
Correct.
for example, we understand when you are let's say intention behind this one is in case if node 2 fails, the full load will be carried by node 1,
Node
and
1.
as a client there will be no like no downtime or no down on the
Correct.
system. The system is still available.
Yeah, the service will be
Okay, so
available.
now
Yes.
let's say, for example, you have node 1, okay, hosting anything, any services or anything, but at the capacity, limited capacity. Yeah. Or let's say in other way around. So now let's say, for example, if we have a node 3, which is like standby, which is acting as a standby, like standby for
you wanted
node
to
1
add
or node
more
2.
nodes? You're saying
Yeah,
you want?
yes, in case if node 1 fail, that will fail to the standby node, not to node 2.
Yeah. Yeah. So the service would be made available. So that's the purpose here.
Yeah, this is what we understand. Yes, but I mean, behind the service, we want to also, like catch to some extent. The service is available. Okay, very clear with this explanation. But this service will be available with the standby node, not with the let's say
active
backup
node.
other active node.
Yeah. So there are multiple methods for configuring the redundancy. So that is active, but that is the active and active passive. So there are two main redundancy configuration. One is this active when we say both will act as an active, and there will be a load balancing thing. So this is one way of configuring the redundancy, and another way is active and standby. So this is the one that we are looking at.
Yeah, but
and
the third one will be the standby.
Yeah, there is a further extension of that. It would be like there is a little bit of theory, that is a quorum, and I forgot the terminology. So they have that how many number of in case of having 6 nodes, how many of them we will have to keep that as active, and how many of them we will have to be keeping it as standby and things like that. There's a calculation behind that. If you're going to have multiple redundancy backups or standbys.
So for us, we have like active standby. So we start with 2 nodes as active and 1 as standby. It depends on each side. Somewhere we have 5 plus 1, so 5 active and 1 standby.
So 2 nodes is what I've just taken. So are you, in case if you want to have the more number of nodes, and which you would like to make it more and more redundant, so there is a way for it. So that is what I was trying to tell.
So in this case, node 1 will be active and node 2 will be standby. How we will be continuing?
Correct. Node 1 will be active and node 2 will be standby. And node 2, if you put it as a standby, node 1 will become active. And the idea is node 2, we will, once node 2 goes down, so the idea behind that is to fix that node 2 to bring it, to bring that up. And we will, once that is brought up, so we will again put that back into the cluster. And then again the 1:1 redundancy will keep going.
Okay, Alex. Yes, at least with this, we can say this is one kind of let's say arrangement. Yes, we can. Let's proceed with this one. And then based on how we proceed, then we might see also like a third node. If you introduce the third node, how it looks and so on. But yes, with this one, let's proceed. This one, no problem.
Yeah. Okay, so this is what is the redundancy types, and you are talking about the active and passive. So how many standbys that we can have? So maybe I can get back to you in the next class. So how many standbys will create the redundancy part will be strengthened. So likewise, there is a concept there. So
yes,
and there is a formula also to have this many actives and this many standby, and we go for nodes more than 2 and things like that. In case of active and passive. Okay. So yeah. So this is all the steps. Okay. So first I will how do we want to do this? So there's a big list of steps. I just thought like initially I'll just go over it. Yeah. So group high available. There's a mistake here. Okay, so the installation steps or the setup is basically you can start it with by installing these two repositories, high availability and resilient storage. So there's a group install, there's a command there which will install all the packages which are a part of high availability and resilient storage. So in case if these things are uh, not enabled, so we may have to enable using the config manager. There is a yum config manager, and we may have to make it enable. So
I mean, when you say these things, means that the command for group install or
high
something else?
availability and resilient storage. So when we give this, so sometimes it may say that it's not. I mean, that's not found.
Okay.
The yum config manager needs to be enabled. So there are many repositories in CentOS, out of which generally we are not taking all of the repositories. So sometimes all of the repositories may be there, but we do not enable. We keep that as deactivated. So if you want to enable it, we may have to enable it and then give a update, yum update.
Okay.
So then it will bring all the packages. It will be a very, I mean, it will take time for us to install both these things.
So this is under which repository? Which
the
one to be
CentOS
enabled for this one?
CentOS. I'm just talking about CentOS.
CentOS,
Maybe the
okay.
yeah, same would be the same for Red Hat as well. So should be the same for Red Hat. I'm taking CentOS 9. Red Hat 9 you can take, or HCL 9, both are same.
For this, which one should be enabled? Which repo is the config?
The name of the repository is high availability. Maybe I'll just quickly show the my system. I have these 4 nodes, VM1 and VM2 or the VM1 and VM2 are the nodes, and VM3 is my KC server, and the RHEL9 VM3 is my virtual IP server. Okay, now I'll show the repository. You see here, so these are the repositories, resilient storage. This is the one, so and its mirrored site is here. And the same way, if you go up,
High availability.
high availability is also
here. Yeah, this one.
High
this
availability.
One. Debugging. Okay. Yeah. Very good. This one, Alex. Can you please save this one in the script folder? This repository yum.repository folder itself, not the location. If you go back to the parent, if you exit this one, please.
So the thing is, so actually, it is there by default. This mirror site, I not created it. When you install CentOS server, it will be there by default. I don't have problem in sharing it. I'm just saying it. I have not done anything. I'm not done any changes.
No worries, because for us is all removed. We don't find this one, so unless we go through the fresh installation and so on. But at least we want to keep it as a reference in case we want to do for time being. This is the only intention.
Oh, okay.
So we know what kind of default repositories will be there.
Okay. Then there are 3 repository files here. So
yes.
I'll
Yes.
put all 3
for our reference mainly. Later on for our reference. So now we know what is the default.
Not a problem. Yeah, not a problem. Clear. So I can put that.
Okay.
So 3 files are there. So addons.repo, CentOS.repo. CentOS.repo are the base repositories, and Red Hat specific things are here in this page. Okay.
Okay, so all three you can save it for our reference. We can keep it.
Yeah. So yeah.
Thank you.
We'll take a note. 1 second.
Please, yeah. And this is the local repository. And when you move to the client side, it is just pointing to this local repository. That's it for anything.
Shall I put it in the same
Yeah, it's okay. No, it can
in
be
the
in the
script
same
file?
script, and yeah,
Script
just make
location.
one subfolder. Yeah,
Yeah.
we
Okay.
can make one subfolder as a repo. That's it.
Repo files
And
then I'll put.
yes, this is for the local repo. Yeah, this is what we understand. And this one. And if you take on the client side, VM2, normally we are pointing this to the local repository. But if you can go there, please. The same copy for the client, if you can save it.
Yeah. Okay. So for the client. Okay. Local repos dot repo. So this is the URL you have to. I am pointing to my local
Yeah,
site.
clear. Yeah. Yes,
So
this one
same way high
we can
availability and
understand.
resilient storage, both of them.
Yes. That
And
same
if you
folder,
give,
if you can copy it.
oh, you want this also? Okay.
Yeah, for the client, yes. But you upload this one or you will upload after the session?
No, I will upload. I don't have any
Okay,
issues.
no problem. No, I mean, because I see something under scripts, session 14 is there. So I don't know, it looks like there is
Oh,
something.
that's a mistake maybe. Please remove it. My mistake, I think I have uploaded.
Okay. I thought it's active.
Yeah. So if you put m repo list, so you will get to know what are the repositories that are enabled by default.
Inside the script, there is 14 session.
Oh yeah.
By mistake, this is what he's saying.
Okay. So that probably you remove it. I think there is a session 14 link is also there. So that session 14 directory will have this session 14 PDF. Is it having?
No. Outside there is no session 14. So
okay.
Yes. We can cut this one and paste it outside if you want.
Yeah. Please. I think I
Okay.
mistakenly did that. I mean, yeah.
No. So we will just done. So under scripts now, there is only one file, let's say, update repo.
Yeah.
So now this two will be added for the client, local repository, and for the client.
Correct.
So these two things.
The update repo is meant for updating my master repository or the server repository. So these two scripts are to update the mirror sites for the master and for the client other repo files. Okay. So that's the thing that we will add. That's the first step we may have to do. And the next step is to install the ISKC server. So ISKC server command is to m install -y target CLI, and there is another one called lvm2. So these two things we may have to install. Let me try to put this.
-y is for some reference. This one normally you haven't installed any package, you know.
Yeah, -y it'll ask us to confirm yes or no. So
okay. That will now is by default we are predefining it. Okay, clear.
Yeah. I've already installed it. However, I'm giving it again.
Yes, please.
Okay, sorry. So this I'm installing it in the VM1. Okay, so this should have been done in this KC server. Okay, so I have space issues. Okay. So this is my KC server. So here I have to install.
When you say ISKC server VM3, Alex. This you mean like you have some storage here or some hard drive extra? What is this one?
I have a hard drive. I just meant hard drive.
The role of this.
Yeah. So if you see my hard disk of this, so I have around 25 GB created for this and managing it with it.
Okay, so the role of this one will be to provide the storage for node 1 and node 2.
Shared storage.
Okay,
Yes.
okay. So you will be expecting to create the volumes in this one based on our size.
Right.
Okay.
That's correct. Yeah.
And then the other one, RHEL, is what is the role of this one?
So this is the virtual IP server. So I am taking this one of the IP of this server is what I am taking it for as a IP address through which we can avail the services for the client. So this is the IP address for the for the clusters front end, cluster facing IP. So this is the cluster facing IP for the clients. So if you see the picture here,
so means
for the
this
clients,
RHEL VM3 will be pointing to node 1 or node 2, anything based
it
on
will be pointing to the cluster resource. It's not pointing to neither to node 1, node 2, node 1 or node
okay.
2. It will be pointing to the cluster's shared resource.
Okay.
So that's the reason
at
it is.
this VIP. So what is that service taking care of this heartbeats between node 1 and node 2? Is there a specific service?
That's as a resource. Virtual IP is acting as a resource to the cluster server, cluster pacemaker. So we may need to add these services to the cluster. So this virtual IP will have to be added there. So cluster will have essentially the shared storage, that is number one, which is the file system. Number two will be the web service, that's the web server related website and things like that. And third one will be the virtual IP. So all these three resources will form as a cluster cluster resources available for the users.
Okay, but this needs to be having a dedicated server.
Which one? Yeah.
This,
so the virtual IP server, virtual
yes.
IP. Yeah. So I have put it as a dedicated server. So there are ways that, I mean, they're saying like we don't need to have a dedicated server, but we need an IP to do this. So I have taken it as a server. I have taken a server which is, but I have not put that as part of the cluster though. I have not put that as a part of the cluster. So
we will see the configuration for this when we go to that VM. No problem.
Yeah.
I just want to understand how you set up this.
Yeah. Okay, so this is one first command. Next command would be to create the physical volume group and the logical volume. So if you see in my SCSI server, so I have created all of these. So if you go to the SCSI, this is my SCSI server.
V3 you mean? VM3?
Yeah, VM3. Yes. SPL. So this is my SCSI server. So if you see VG iSCSI, LV iSCSI. So this is my shared storage that I've just created now. So that's a first step. So this is the shared disk that I've created. I've just installed my SCSI server, LVM2, and this shared disk. So this is what is created as part of the second step after having this installation. So one more thing is actually this group install of high availability resilient storage should be should be done across all the nodes. So we have to make sure all of these nodes are having these packages with the same version. So that is one thing, and they are also telling that we may need to make sure that the time date is also synced up properly. So in case if the nodes are not going to give or not giving proper times, so I made it like this. This is also a prerequisite. So if you see time date CTL and this time date, these are two nodes, time date CTL. So these two nodes essentially should show the same timings.
Yeah, just one question, Alex, related, because it's a touch this one. So if you go back to this time that, okay, yes, here, so you have, you don't have NTP here, synchronous clocks. So why this system clock synchronized? No. Service is active or enable, let's say, but why system clock synchronized is no. We have a control for this somewhere?
Yes, we can control, not an issue. System clock synchronized. No, so because I think the local clock is not considered. I just enabled NTP alone because previously it was no for NTP as well, and it was just showing some clock. So I just enabled NTP, and there's a way to synchronize or force synchronize the NTP clock from the NTP server, public server. So there's a thing called cronny. Like some command.
Sources cronny.
Yeah, cronny minus a make step. So this is a cronny C. So this.
Yeah, what is this one?
So this will actually cronny C minus a make step. This will actually sync up the clock from the public entity server. So in case if you find some difference, all that you have to do is make the NTP service active. That is yes, and the way to do that is time date CTL and set
this one we know
NTP.
This one.
Yes.
The question was only for this synchronized.
Synchronized. That I think I've not tried that, but we can do that by giving, if you see time date CTL and system clock. System clock synchronization. Maybe this one. Local RTC. So I think this is the one. Local RTC. I think this is the one, but I don't want to do this now because it should not give any other issue. But I think what I understand from here is currently it is not updating the local clock, the RTC clock. The RTC clock is my local clock.
So it's gone, yes.
So that is out of sync, which we can see that it is clearly that it is out of sync. And I'm running my clock based on the NTP.
Yeah, but now clock synchronized is yes. So you didn't run anything, right?
Yeah, I did not do anything. Set the NTP. That's what I did. Oh, it's okay. Maybe I think okay. So I did set the NTP, yes. So maybe that time he is actually synchronizing my local clock. Maybe NTP gets syncing happening maybe once in a day or so. Unless otherwise if I explicitly give set NTP yes, which might trigger. Maybe.
Okay. Okay, but I think that's different. But anyways, okay.
So yeah, so why I told this is so that is why I mean that's one prerequisite. That prerequisite should be time date CT. I mean time should be same for all the nodes, and all the packages should be installed on all the nodes. These are prerequisites. Okay, so coming to the so we have installed the ISKC server and we have created a shared disk. Now we have to install the initiator in the nodes. So I yum install -y ISKC initiator -utils LBM2. So these two things we have to install, and then we will have to bring up the ISKC D. And then we will have to get the initiator names. So by giving this command, we will be able to get the initiator names for our nodes. If you give this command. So this is the initiator name, initiator name for node 1, and this initiator name for node 2.
And here, Alex, this one, this high availability and resilient storage, the package that you're saying we should install across all the nodes. This package is what you were referring to, the Pacemaker package. That is different, right?
Pacemaker is available in high availability. Resilient storage things is all related to the LVM cluster and the ISKC. So both the things are available in the resilient storage.
Pacemaker and Porosync and all the storage,
all the things, all the high availability.
Under high availability package. We can install it separately also, no?
Yes, we can install it separately also.
Then we don't need to say group install, just install it.
No, yes, we can do separately also, not an issue. We can separately also.
Okay. So this is actually the package for all Pacemaker, Porosync, and the
high availability is the, yes, high availability is the repository which will have all the list of packages for the Pacemaker, Porosync, and everything.
Okay, clear.
Okay. So initiator for the nodes are done. So then we will have to map the shared disk with of the ISKC client. So for that we will have to go to the ISKC server by giving target CLI, and then we can give back stores. So target CLI will give the ISKC prompt, and we can go to the backstores block and we can create the ISKC shared storage. So there's a command to create the ISKC shared storage and give the logical volume that we have created. So which will create the shared disk in the ISKC server. So once that is done, so we can go to the ISKC and pick up the IQN number in the TPG. So this is one thing that we may have to note, which we will have to use it for discovery in the clients. So this ISKC, go to the ISKC directory, and then we will have to say create. This will create the IQN number for the shared disk. Then we have to go to the ACLs directory under the IQN by putting the IQN number, TPG1 and ACLs, and then give these two IQN number of these nodes. I have to know two IQN numbers of these nodes, which we have taken down by this command. So both these things have to be created as an entry to these ACLs for this ISKC, so that this ISKC server will allow this shared disk to the ISKC clients. The clients are identified by this initiator names, identities. So once that is done, we can go to the lens. We may have to create the lens. Basically, the lens is the logical unit number. So this logical unit number needs to be created, and this logical unit number can be created by getting into the lens directory, and then we will have to specify the ISKC shared storage to create the lens number. And once that number is taken, so we have to save config and exit. So with this, our job with the ISKC server is done. So once that is done, we may have to restart the target and enable the target. Target is nothing but ISKC service. And once this is done, so this shared disk would be available in both the nodes. So if you see here, so my shared disks are available here. This is a 5G shared disk that I created. So this is the 5G shared disk, and this is my ISKC thing. And the same thing, I've got it once the ISKC is up and running. So we'll have this 5G available in the SDC. So I this SDC disk would be available in both of my VMs. So initially that was the case, and once the SDC is available, we can go to one of either of the nodes and then create one logical volume. So the logical volume, I created a volume group by name VG Apache, and in that VG volume group, I created a logical volume, which is called LV Apache. So I created both. Since once it is created in one of the nodes, it will be visible in the other node as well. So by default, it should be visible. But in my case, it was not visible. So I had to do some workarounds of like what I had to do was this commands I have to give VG restore VG Apache. So this is to restore the VG metadata corrupted. So this is one thing, and LV change, it was not active in one of the nodes. I have to make it by giving LV change. So once that is done, so in both of my nodes, this shared disk started was visible. So now my shared disk is created in the ISKC server, and it is visible in both of these nodes. Now coming to the we may also have to make the firewall enable to for the ISKC to work, so that we will have to do. So then only the shared disk would be available for us to see. So this is a command to enable. 3260 is the port number which through which the ISKC would communicate, to make that available or allowed in the firewall and make it permanent. And the LUN that we created has to be discovered in both the nodes. So the command to discover that is to ICS ISKC ADM minus M and discovery, and then we can give the IP address. So this IP address of the ISKC server. So once we give this thing, so it will give the LUN number. So maybe I can show it to you. So this is showing there are two nodes which are connected here. So this same thing which we can see in the other node as well. Two nodes are connected, or the shared disk is being shared with two nodes. So that's what we can get to know by this. Then what we have to do is we need to map it using this command to our site. So the LAN number that we had received, we will have to map it to our local site, so that it is available for us to use. Once by giving this command, we will be able to see that available in our system. Once that is seen, then only we will be able to see the shared disk in both the nodes. And after that, we will have to create the physical volume group, LV logical volume, all of these things. Once we create these logical volumes that we have created should be visible in both the nodes. So in case if it is not visible, so we can give these two commands, LV change and VG store. In this happened to my case, in my case, so it was not visible. It was when I created in one node, the shared disk was visible, but the LVMs were not visible. So I struggled a bit to get this visible. So there was some metadata corruption was happening, maybe look like that. So when I gave this command, it was visible. Okay, and yeah. Okay, HA cluster configurations is going to start now. So this is these are the configuration now. Which in first thing is we will have to enable the high availability in our server using this config manager set enable high availability. So afterwards we can give Pacemaker, PCS. Pacemaker is left out by mistake. We need to say. Pacemaker, PCS, fence agents, all PCP, 0conf, all of these things we'll have to install. And so if you do a group install of high availability, it will install invariably all of the packages. It doesn't. We don't need to specify any of this. If you just say all the packages are high availability, and that's a ideal suggestion, best idea. So that's a good idea to install all the packages of high availability and not specify only few things. So
what is that of the packages? This Pacemaker, PCS, fence agents.
Fence agents, all PCP 0conf. So I've just given 4 packages. Later on, I had to install few other packages then and there when it was giving some other issues. So it's better to install all the packages of high availability at the first shot itself. That's what I'm trying to say.
Okay. Because it's not good at the same time to load to overload unnecessary stuff, right?
Yeah, but I am using
there will be
virtual.
dependencies.
Yeah, but your thing is a corporate data center, right? So this should not be a bigger things.
Okay.
Should not be of much concern. I have just VM, so I was little concerned about that, but I don't think it's not too huge. I mean, as you imagine, so high availability is not very huge, and resilient storage is also not huge, and it's all.
Okay, no problem. And this Pacemaker PCS pen is separate, no? Because resilient is high availability already installed, no? Now here you are enabling it.
Yeah. So that's also
the
a
second
mistake.
line you are enabling it. Then the third line, what you are doing here again?
Yeah. So the thing is, it's a repetition. So we could have done it if you have already done it in the first step. So we don't need to do this. So that's
okay. So we thought it's like this separate. Okay.
Yeah, if you already done that, so we don't need to do it again. So if you already done
okay. Basically, behind a high availability and resilient package, these are the 4 high packages we need.
Yeah.
PC Maker, PC fence agents, all PCP 0 config.
Yeah.
Okay.
Yeah.
Okay. Keep it like this, but just maybe in the bracket you can say like a repeated or.
Oh yeah.
Something like
or
this.
I will remove this because it's coming up as a step, right?
Or put it under in the previous slide because we need to have this reference. Or put this one under the.
So let's say.
Okay. This part of installation. Okay, yes.
If
repeated
it is done,
slide for information.
If it is already done as on step 1, not.
No. Oh, yes, different text for us. As you know, but keep this one, please. Yeah, we will take it as a reference.
Yeah.
Okay. Okay, that's good.
Yeah. So. Yeah, so so far we have done ISKC setup. So now we are getting into the cluster setup. So shall we go ahead now, or it may take more time. So shall we take it in the next class?
Yeah, for the next class, I think it will be better.
Yeah. Okay. Yes. Okay. Sure. So, however, I'll send this. I'll put this slide also in the thing.
Okay.
For you to take.
Okay. The YUM repositories for local server and the client plus this one. Okay.
Yeah. Okay.